All right, people, brace yourself. This is lesson 3 on, by far, calculus's most famous and definitely most useful law, and it is called the chain rule. Like 2 chains. Anyway, 2 chains. Okay, chain rule. So the chain rule is extremely useful. We are going to use it probably in every problem from here on out. What it does is allows us to deal with functions that are within a function that we've been dealing with and you didn't even realize it. So, like when we had something like this, we were looking at that and multiplying it out because we didn't know what to do. What did you take the derivative of? So instead, we were multiplying it out and then, saying x squared plus 4x plus 4 and getting it into a place where we could just use product rule and we could manage it there. But that can get like super annoying, especially if we have something that looks, like this. I don't want to multiply this out 5 times. So this is where the chain rule comes in. And what chain rule says is that if you have a function within a function, then you take the derivative of the outside function and multiply it by the derivative of the inside function. So let me write this out for you. So we're going to say if we have capital F of x equals f of g of x, right? So do you remember when we did composite functions and we were like, okay, well, you've got this kind of like, this outside function. So you've got f of something, right? And then within that, you've got g of something. And what we're saying here, the rule is that the derivative of this is going to be the derivative of f of x times, let me rewrite that. So that's the derivative of f of g of x times the derivative of g of x. So we're going to look at these in separate pieces. The notation on it is frustrating. I get it. So let me show you what it looks like. All right, let's say we have, why is this here? Hold, please. Great, thanks. Okay, so let's say we're dealing with f of x equals 2x squared plus 3 to the third. Okay, so we've got an outside function here. We have something to the third, right? Something to the third. And we have an inside function, which is our something, which is 2x plus 3. So let me say that again. We have something to the third, which is our outside function. The inside function, and by inside I mean inside the brackets, is 2x squared plus 3. So we are going to take those derivatives separately. So what is the derivative of something cubed? Well, it's 3 something, right? Like if that had been an x, we would just leave it an x. 3 times something squared, because we need to drop our exponent by 1, right? So can we agree that that works? Now, what is the derivative? So that was kind of like the red part. The blue part is 2x squared plus 3. Well, what is the derivative of 2x squared plus 3? Well, the derivative of 2x squared is 4x. And remember, we said we're multiplying, is 4x, and the derivative of 3 is nothing. So our derivative is 3 times 2x squared plus 3 squared times 4x. Now, if you're looking really closely, we could also put just a bracket around that 3, right? So I can take my 3 and my 4x and multiply them together, and I'm going to get 12x. Not much I can do with the other bracket because it's squared. I could multiply it out, but that seems inefficient at this point, so I'm just going to leave that. Is 2x squared plus 3 squared. That's it. That is how you do chain rule. Okay, let's go through another one. I might ease off a little bit. Let's back up the train a little bit. Let's say we have x plus 3 squared. In this one, I'm looking for the derivative. I have something on the inside, and then I'm going to square that something. So we're going to start with the outside. What is the derivative of something squared? Well, it's 2 something, and then if product law, drop the 2 to a 1. Now, what is the derivative of that something? What is the derivative of x plus 3? If I just gave you x plus 3 and said, what's the derivative? The derivative is 1, right? Derivative of x is just 1. So this one's actually really simple. We can, distribute your 2 and get 2x plus 6 and, times 1. Sure. That's it. You want to try one? Let's try this. Find for me the derivative of 3x squared minus 4 to the third. Hit pause. Try it. Okay, what'd you get? Let's see if this was what you did. All right, so our outside function here is something cubed. Well, the derivative of something cubed is 3 something squared. I know that 3x squared minus 4 is in here. Is it easier if I color code it? Now I'm going to multiply by the derivative of 3x squared. The derivative of 3x squared is 6x. If you put brackets around this 3, it suddenly becomes really easy to see that these two things can multiply by each other. I cannot multiply or distribute into this because it's got an exponent, so don't let that get you. So therefore, this is going to be 18x times 3x squared minus 4 squared. Done. There's your derivative. How'd we do? Let's try another one. Let's try this. Y equals x squared minus x plus 2 to the 8th. Try it. Hit pause. Okay, ready? Our outside derivative, or our outside function, is something to the 8th. Let me put some color here. So I've got something to the 8th. That something is a function. It's a red box, whatever. Something to the 8th. So the derivative of that is 8 times something to the 7th. And I'm going to put my x squared minus x back in here. Now I'm going to multiply this by the derivative of that something. So what is the derivative of x squared? 2x. The derivative of negative x is negative 1, and the derivative of 2 is nothing. So here's our final answer. Now, ask yourself, is there anything I can kind of clean up here? Again, if you go and put a bracket around that first number, sometimes it's easier. We cannot distribute into this bracket because it's got an exponent. You can distribute that 8 over here. We could do that. It looks a little better. That would give us 16x minus 8, right? If I had distributed here, times, times that x squared minus x plus 2 to the 7th. Don't lose your bracket or your exponent. Okay, good. Want to try another one? This one's a little trickier, why not? Let's go for broke here. All right, what if we have this? 2x squared, the square root of 2x squared plus 3. Our outside function this time is the radical. So like everything else we've done in this class, we need to put it into exponent form. So before I take the derivative, I'm going to rework this in exponent form. So I'm going to put it in brackets and put it to the half. Now it looks like everything I just did. Now I've got something, a red box to the half. Well, what is the derivative of that? It's 1/2 times my something to the negative 1/2, right? And this was 2x squared plus 3. I'm going to multiply by my 2x squared plus 3, which is 4x. Now, you've got a hot mess on your hands. Be really careful. This 2 is in the denominator. When you drop this bracket down, because of its negative exponent, it's going to go into the denominator with the 2. This 4x, I can draw that over a 1, right? Which means this 4x is in the numerator. Be careful. So what does this look like? I'll draw myself a fraction. We'll start here. So my 1/2 has a 2 in the denominator. I'm going to drop this thing to the denominator, and I'm going to put a radical over it because of the half. So this is going to become 2x squared plus 3. Up here, my 4x is going to go in the numerator. And then, as one final step, I'm going to look at this 4 and 2, and I know that 4 divided by 2 can simplify. So that my final answer is going to be 2x over the square root of 2x squared plus 3. How'd we do? Is that one okay? All right, let's try a couple. I'm going to give you 2. And I'll tell you the answers at the end. All right, here, practice with this. Um, 3x minus 7 to the 12th. I want you to differentiate that. And then I would like you to differentiate the square root of 5x minus 3. See how you do. Well, I'm going to post the answers now, and then I'm going to give you some practice problems in a PDF that you can work on your own. So hit pause. Don't look at this until you're ready. Okay, here's the answers. The answer to number 1 should be 36, 3x minus 7 to the 11th. And the answer to the second one should be 5 over 2 times the square root of 5x minus 3. Okay, cool. Bye.